Well, hello everyone. In this video, we're going to see how the expected value, covariance, and correlation works. So let's see. What is expected value? Well, imagine we have a function of this one, x, y. We have only two random variables. Now, the expected value is going to be the most likely value that is going to is going to be the most likely value that is going to we are going to obtain with this function, given the probabilities that the certain probabilities that appear here. So how do we calculate it? Well, we want to get the expected value of this function. It will be equal to the sum of the data in x and y of the function times the probability of each value of each pair of value. So, for example, we can have the expected value of the coin. For example, when we have tails or cross, we can calculate the expected value of each function, given that we have the probability and the form of the function. We can also do this not only for discretized case, but also for a continuous case, which we will only substitute with interval functions with our the function and with our notation for the function in continuous cases, and this will give us the most likely value. Now we can say, for example, if we have x equal to x for before, and we have, for example, a case where the probability of each of them is equal to 1/100 in each case, then we can easily get this part. So let's give that x going from 0 to 10 and also y. So for this part, if we assume that we have a continuous case, we can easily calculate this as the integration of over 0 to 10 in each part of x times 1/100. And this will give us the expected value of all these functions. So it is a pretty easy thing to get. Now, when we have two random variables, there are sometimes questions like how correlated are these two functions? How likely? How are they like one of them affect the other? Like if x grows, also y grows. So this question can be answered with some function that calculate this kind of part. So the first one is called covariance. So covariance, and this is represented as covariance of xy is equal to the expected value of x minus expected value of this times y minus the average of y. And this it will give us the covariance of all these results. Why this gives us how likely are they related? Because, for example, if x grows at the same time and y grows, this will give us a really high covariance, and if both decreases, this will give us a really low covariance. So with this value, we can calculate how related they are. The problem with this covariance is that the measurement in it really affects how these quantities work. So what people do is that they do other function that is called correlation. That is defined as correlation of Vx, while a covariance of x over y over the standard deviation of both, while the multiplication of standard deviation of x and y. This is to avoid all the units that affect this covariance, and we have a value that goes from -1 of Vxy to 1. So this will give us a more exact form to relate the correlation. So for example, if this is equal to 0, this means that they are not correlated. So this is a much better way to check that. The problem with these two kind of to check how related they are, they only check if they are related in a linear way. They don't check, like, for example, if they are exponentially related or polynomially related. it only checks linear correlation. So this is one of the biases and one of the things you have to take careful attention when using this kind of tools. So thank you and see you next time.